Hello, I'm Mr. Love, and this is our Introduction to Engineering course. In the next few minutes, I'm going to take you through some of the details of the course, some of the things you can expect, and what our course covers. So sit back and enjoy. So in our Introduction to Engineering course, one of the core principles is focusing on interaction. So what we really do, sort of overarching across all the engineering courses here at MHS, is explore engineering design process using group work and technology as a tool. And so we try to extend that collaborative work outside of the classroom, and essentially everything is project-based. And so these projects will always follow the engineering design process. Generally they last 6 to 8 weeks in duration. Some are longer, some are shorter, and the students have a variety of different roles. So, sometimes they're leading the groups, sometimes they're responsible for the design aspects, sometimes they're responsible for the documentation parts. The students really use a ton of technology, whether it's the stuff that they bring in the form of computers, Mac, Windows, and Chromebooks. And then we have all sorts of stuff in the lab here that they have access to, things like 3D printers and CNC machines and Arduino and all sorts of interesting technology that they can sort of leverage within their projects. The workflow involves a lot of different steps. So everything is centered around team discussions. So those discussions happen in person. They happen over Zoom and shared documents. They keep a physical engineering design journal, so they're actually writing out in a book some of their findings and the process that they're using to design things. They submit essentially all assignments digitally, so they're making a lot of scans from this engineering design journal and using digital tools and submitting links to those. Lots of CAD, Fusion 360, and some Onshape. We also use things like Trello and Lucid, Microsoft Teams, really to bring everybody together, and that's the most important thing. In terms of our units of study, we start thinking about inventions and innovations, like really what is technology. We move into a basic overview of the engineering design process, things that are around us that are engineered, and how engineering systems sort of tie together subcomponents and how we can think about larger problems in terms of these smaller systems. The technological inventions and innovations is really just a history of technology, how current culture and even social media affects the marketing of technology and sort of our interaction with it, and the importance of research and development. And so thinking about ways to solve problems and the tools that we have to solve those problems. The engineering design process is really one of the big things that we discussed this year. Talk about collecting and finding information and how we use that information, principles of good design, understanding criteria and constraints, sort of limitations within our design, creating prototypes and modeling, which we do a lot of physically, and then really applying this design process and creating documentation so that others can share in our work. The design world is really sort of where we dive into a bit of a survey of the different styles of engineering or the different sort of branches in engineering, how we interact with it, everything from biomedical engineering and agricultural engineering to civil and electrical, and this is really a bit of exploration. And then another big part is engineering systems, where we concern ourselves was really breaking down engineered items into various systems that sort of come together to do one function. So we talk about the universal systems model. We do a bit of reverse engineering and troubleshooting and understanding how this helps us solve problems. And that kind of brings together the entire year. One of the key focuses, if we think about an overarching idea, is this idea of human-centered design and the fact that the things we make really ultimately are always getting used by a person somewhere. And thinking about these three things: desirability, viability, and feasibility. So desirability, whether or not people want to use the thing that you create. Feasibility, if it's possible. So if you can actually make it using, the current technology and the tools that you have. And viability, is it something that can maybe be produced or marketed or sold in a business framework, although we don't focus too much on that aspect of it in this class. And when we kind of get all three of these, this is where we have innovation and we can innovate. We also run lots of things beyond the classroom. So Robotics is a big thing here at MHS. We have a lot of connections, within the community. Things like the Large Magnetic STEM Alliance, where we participate in the first Tech Challenge, so that sort of brings together multiple schools. Mate Robotics, which is underwater robotics. We travel to go do that. Things like the B Team Engineering, that design sort of within our agricultural systems. And then as the students move forward and upward in our pathway, sort of capstone classes like collaborative design, where we're really trying to forge community relationships and take our stuff really far outside of the classroom. So I really appreciate you stopping by and watching a little bit about our Introduction to Engineering course. I'm happy to answer any questions concerning our program, this class in particular, or what the other classes look like, and look forward to seeing your son or daughter in class.